All right, so on the bottom of the module for the review was that 3.1 to 3.4 extra practice. So I'll go through them. They may not be in the order that you took them, so you might have to like sort through yours to find the ones that you should have gotten, okay? But they're all there. They're all the same question. They were just in different order. So number 1 was 3 to the x minus 3 equals 32. You had to convert 32 to be 2 to the 5th, and then the bases were the same, so x minus 3 equaled 5, and x is 8. Most everybody got that question right. Any questions on that one? Okay, good. The 2 and 3, I'm actually going to go back to when I do the review because I'm going to break those down into all the parts like intercepts, domain range, asymptote, and graph it. So you can see them all put together. Just remember that the intercept itself should be a coordinate point. So it should be 0, 5, not just 5. Okay, and certainly not y equals 5 because that would be a line. Number 4 said 2 log base 3 of 1 over 27. So that one can actually be done a couple of ways. Like I saw people do it as 2 log base 3 of 1 minus log base 3 of 27. So they expanded what was inside that fraction, which is totally fine. This would be 2 times 0 minus 3. And then 2 times negative 3 is negative 6. So that's one way to do it. The other way is just to see that 2 log base 3, 27 would be 3 to the negative 3. And then you can do 2 times negative 3. Or mental math, log base 3 of 1 over 27 is negative 3. And 2 times negative 3 is negative 6. So there's more than one way to do those. I'm not going to tell you that you have to do it one way or the other as long as you can get to that answer, whichever way makes the most sense for your brain. Okay, 5. Again, I'll get back to those. All right, 5 and 6 I'll go back to because those are both the based on the graphs. And then 7 log base 4 of 2 plus log base 4 of 32. So sometimes you can separate these independently and then add them. And you actually could do that with the first one. Like I could make log base 4 of 2 1/2 because the square root of 4 is 2. But I can't do that with log base 4 of 32. There's no power I could raise 2 to get to 32. So in the case like this, you had to condense first. Once I condense, I'd get log base 4. When I add, I multiply these, so I'd get log base 4 of 64. And 4 to the 3rd power is 64. So that's 3. And then 8 is probably one of the more commonly missed questions. So remember when you're condensing and you're dealing with addition and subtraction, that if it's positive, it stays in the numerator. If it's negative, it goes to the denominator, no matter what order your statement is in. So the one that is positive, or the ones that are positive, each of these would have gotten bumped back here and here and here. So I would have gotten log of x to the 3rd minus log of y to the 4th plus log of z to the 5th. And then everything that's positive goes to the top, which means I get 1 log. X to the 3rd would be in the numerator. Y to the 4th would be in the denominator. And z to the 5th would be in the numerator. So be careful, because that could be done in any order. Like I could bump negative 4 log of y to the front, and because it's negative, it still goes in the denominator. So positive top, negative down. And then 9 was a solving log 4x equals 3. So that is a log base 10 of 4x equals 3. 10 to the 3rd equals 4x. 1,000 equals 4x. And x equals 250. And that initial one had a log in it, so you would want to make sure that you check by plugging it back in. Obviously, plug it back in and checking it makes your answer confirmed. But what you have to do is, even if you don't have the time to confirm the answer, plug it back in and make sure it can be done. So if I plug the 250 in, multiply it by 4, I have a positive number, and that's what works. You cannot take the log of a negative or of 0. And then the last one, you were condensing first and then solving. So you had to take, there was a log on either side of the equal sign. You got to take that log, condense it on the left-hand side. So because it was positive, it becomes multiplication. This is log base 2. Log base 2 of x plus 6. And then I would, because both log base 2 is on the left-hand side and the right-hand side, I can use the one-to-one property to say x times x plus 2 equals x plus 6. distribute this. As soon as you see the x squared and the x, it should be your indication that you're going to have to factor. So I'm going to get everything, or use quadratic. Get everything to one side, so subtract the x and subtract the 6. X squared plus x minus 6 equals 0. And then this is factorable. So factors of -6 that sum to +1 are what? -2, +3. And I get 2 and -3. And here's an example where we have to check, right? So I have 2 and -3. I'm going to come back up, and everywhere there's an x, I'm going to test those points. So if I plug it into the first x, 2 is fine. Here, 2 plus 2 would be 4. That's fine. Here, 2 plus 6 is 8. That's fine. Then I have to take and plug in the -3. -3 here can't be done. So I rule it out. It also can't be done here, but I only need it to be done, not able to be done in one spot for me to rule it out. So I would cancel out the -3 and just keep the 2. Questions? Again, I'll go back to the graphing ones, but all of that stuff is stuff that's fair game for your test. So logistics on your test, it is sections 3.1 to 3.4. It is Tuesday of next week. You will get separated out a part that has a calculator and a part that does not. That means that the sections are shuffled, right? Because there's some things from 3.2 you can't do without a calculator. There's some things from 3.1 you can't do without a calculator. And there's some things from 3.4 you can't do without a calculator. So it's not like 3.1 through 3.3 is no calculator and 3.4 is. It's kind of shuffled around. So that makes instructions so very important. Make sure that you read them carefully. They all have something to do with exponential or log. That's the good news. The whole chapter's like that. But you got to be really careful. So 3.1 started with the graphs of exponential functions. And this is the actual example from the extra practice. So I'm going to work through it so you can see the domain, the range. The y-intercept was on the extra practice, but we're going to go further and get the horizontal asymptote and actually graph this. So consider this to be without a calculator. I would not give you a graphing question with your graphing calculator. So when we're dealing with exponentials, what are we plugging into? The x or the y?
The x.
The x. How do you know it's exponential? Because they're going to get grouped together. Is it going to say graph the exponential function? Nope. It's going to say graph. What's the difference between log and exponential? Hint. Log has the word log in it. Right? Log will either be log or ln. Those are the ones you're going to plug in for y. Everything else you're going to plug in for x. So into my x goes the -1, the 0, and the 1. So 3 to the -1 plus 2 minus 4. And then I'm going to do 3 to the 0 plus 2 minus 4. And then I'm going to do 3 to the 1 plus 2 minus 4. So this is 3 to the first minus 4, 3 minus 4, which is -1. This is 3 to the second minus 4, or 9 minus 4, which is 5. And this is 3 to the third minus 4, 27 minus 4, or 23. With me so far? Yeah. Now I'm going to plot those points. Way up here. If I didn't know any better, it almost looks like a line, so you have to be careful and know that this is exponential, so it takes a curve, and also know that it has a horizontal asymptote. So when there's a exponential function, it has a horizontal asymptote, and that horizontal asymptote is based on your vertical shift. So if there was no vertical shift, then my horizontal asymptote is where? 0. If it's down 4 places like this one, where's my horizontal asymptote? -4. And it is y equals -4. It is an equation, okay? Make sure you make it an equation. Don't lose points on silly stuff like that. So now I know my horizontal asymptote looks like that, and my curve is going to bottom out around -4. Good so far? What's the domain of this exponential function? All real numbers. This exponential function and every exponential function. -infinity to +infinity, which should be, so that should be an interval notation. Is your range restricted? Yes. Also based on your vertical shift, right? So this you also get from that vertical shift, which means it's going from -4, not including -4, to +infinity. Make sure that gets a parentheses. So I only had a couple, I think maybe 2 on the quiz, give it a bracket. They're all parentheses this time. Okay, and then your y-intercept can either come from your graph or it should be easily identified from your t-chart, right? So that's 0, 5. And again, it should be in coordinate point form. So I'm going to be picky about the coordinate point form. I'm going to be picky about your horizontal asymptote and your vertical asymptote being lines. I'm going to be picky about your domain and range being an interval notation. Don't lose points on silly things like format. I'm going to do the same thing I did like on the quiz. You're going to get a t-chart. You're going to fill in the t-chart. So I'm looking for that stuff. Don't do these things in your head and then get them wrong and lose all that partial credit. Write out what you're doing so that if you do make a mistake, a lot of people in like something like this, not a lot of people, but people left off the -4 at the end. Something silly like that gets you all the wrong points, gets you all the wrong graph, and if you don't show me any work, I can't give you any partial credit. So don't be foolish about your partial credit and your work, okay? Questions on graphs of exponential. So you could see obviously a variety of things. You could see a horizontal shift, a vertical shift. You're plugging in points, okay? Make sure you can identify all that stuff. Also in 3-1 was your interest problems. So guaranteed interest problems are on the portion of your test that has the calculator. And there's 2 different kinds, either a certain number of times a year or continuous. A certain number of times of year is A equals P times 1 plus R over N to the NT. And continuous is A equals PERT, P times E to the RT. And for these, you want to make sure that R is in decimal format. So if it said 2.5%, you want to make that 0.025. I think the good news is that those of you that made mistakes as far as the computation goes on this, it was mostly the calculator that you weren't comfortable with, and we're back to graphing, so hopefully you're more comfortable with your graphing. Just make sure that when you're completing the review that you're doing it with the calculator you're going to use. When you come in on Monday, bring the calculator you're going to use, and then obviously when you come in on Tuesday, have that calculator with you. Questions on those? I don't need to work through an example, do I? So on your quiz, I can't remember, you guys had, like this one had weekly and daily. Just make sure that you're ready for monthly, quarterly, semi-annually, all that stuff, okay? Because it could be different. In a combination with other ones. Oops. All right, 3-2 came the logs. So you were evaluating logs, mental math, okay? All that stuff would be on the non-calculator portion. So the easy part of these they are mental math. The hard part of these is there's no work to show, which means no partial credit. If you write the wrong answer, that's it, it's wrong, right? And there's no, obviously these are not going to be on a calculator portion, so there's no way to check it. So remember, if the base is any number and the large part is 1, what does that evaluate as? 0, right? No matter what the base is, if the answer is 1, it means it was raised to 0 power. If the base and the large number are the same, you can actually simplify this by canceling and keeping the exponent, which means this is 5. Or now we know to expand, you can bump the 5 to the front if that confuses you. So you can bump the 5 to the front, make that 5 log base 3 of 3, and log base 3 of 3 is 1. 5 times 1 is 5. So you can get these multiple ways. ln of e, so ln came in 3.2. We learned that ln was log base e, right? So if this is log base e of e, then what's the answer? 1, okay? And it's not 1 because they cancel through. It's because it cancels through and gives you the exponent, which is why this one is 5. So this is log base e of e, which means you can cancel through it, but you have to keep the exponent. And if there was something on the front, you'd multiply it. So that if this was 2 ln, well, if this, 2 ln of e, that would be 2 times 1, which then changes this to 2. So be careful when you're canceling through. And then on the bottom, if the exponential function and the log in its exponent are the same base, then you can cancel through this. This is just 5. And the reverse are the same on the right, except that it says log base 7. 7 and log base 7 cancel and give you just 6. So you'll see those. It won't probably be as easy as that. Maybe in a combination, like if this was a plus, and I would have said ln of e plus ln of e to the 5th. That's 1 plus 5, which is 6. Something like that. Okay, because you can. All right, then we got to graphing of logs. All right, so then we got graphing of logs, and again, this would not be on the calculator portion. So this is the example from the 3.1 to 3.4 extra practice, in which I asked for domain and range and the x-intercept, but we're going to go all the way through. So if f of x equals log x minus 3 minus 2, when you're dealing with logs, you're plugging in for what? The y, right? So I do -1, 0, and 1 on the y. So I've got to get y equals log base 10, in this case, x minus 3 minus 2, solved for x. So I'm going to add the 2 to both sides, getting rid of it on the right. And then I'm going to convert this into exponential. So this is a base of 10. 10 picks up the y plus 2. That whole thing is in my exponent. Equals x minus 3, and add the 3. And now I've solved it for x. So I can plug in my y. 10 to the -1 plus 2 plus 3. 10 to the 0 plus 2 plus 3. 10 to the 1 plus 2 plus 3. So 10 to the first plus 3 is 13. 10 to the second, which is 100, plus 3 is 103. 10 to the third means 3 zeros. 1,000 plus 3 is 1,003. So I wanted to do the question that was on the same example that was on your extra practice. I probably would not give you something like 1,003 to graph, but if you did, you could do it. You just want to adjust your graph, okay? So my y values, they're fine. I can leave them as the scale that they are, but my x values are huge. So maybe let's change these to go by 20s. 20, 40, 60, 80, 100. 120, 140, it's still going to be huge, but you can get the idea. 180, 200, so on and so on. So when I plot those points, the first one is 13, -1. And then 1030. And then the next one is 1003, 1. So all the way over here. And again, that's a hard curve to draw until you know where it starts to curve, which is based on this time your vertical asymptote. So remember, vertical asymptote comes from the parentheses with the log. If I set that equal to 0, I got my vertical asymptote, which would be x equals 3. The x equals is important. Without that, you're losing credit. So make sure it's at line, which means x equals 3. So that means that I've got a vertical asymptote somewhere over here. And my curve is doing something like that. Everybody with me so far? Yep. All right, so domain on logs, is that restricted? Yeah, because it's based on your x values, right? That is also based on what's inside those parentheses. That's going to be what sets up the point in which you start your interval notation. So if 3 is where my vertical asymptote is, then 3 is where my domain starts, and it goes to positive infinity. And it can't include, so it gets a parentheses. The range on the logs is what is all real numbers, or negative infinity to positive infinity. And my x-intercept this time from the chart is a lot easier from the graph than from the graph. So it's 103, 0. And again, that should be in coordinate form. So make sure you've got it in an XY combination. Questions on these? So because you're doing these without a calculator, you won't get LNs because you can't be raising e to other power than other than 1. I wouldn't expect you to be able to, or 0. I wouldn't expect you to raise it to anything else. You'll just get logs. All right, also in 3.2 is your change of base. So if your base was not e or not 10, how could you find or evaluate that log? Which one goes in the top? The 5, right? The bigger by size, not by value. So this would be log base 10 of 5 over log base 10 of 17, or ln of 5 over ln of 17. Without a calculator, that's as far as you go. So if this question is on the portion of your test that is not with a calculator, I'll just say rewrite the log as a base of common ratios or natural, of common logs or natural logs. Or if it's on the calculator portion, you'll work it out. So ln of 5 divided by ln of 17, or log of 5 over log of 17 would be approximately 0.568. Everything on your test is 3 decimal places except for the money. The money is obviously 2. Everybody still good? Questions? Okay, then we got to 3.3, which is the properties of logs. So you will either be expanding or condensing. It's just going to say simplify. It might say expand or condense, and you've got to be able to look at it and identify which one you're supposed to be doing. If there's multiple logs or multiple ln, you are condensing. And if there's just one, then you're expanding. So if it starts out as multiplication, then when you expand it, what do? Add, good. So addition. If it starts out as division, then you subtract. And if you're raising up to a power, what happens to that power? Good. So you multiply it on the front. And that goes both ways, right? So if it's addition and it's expanded, then when we put it together, it's multiplication. If it's subtraction and expanded, we put it together, it's division. And if it's multiplying on the front and we are condensing it, then you raise it to the power. So examples of those, notice the difference. Obviously, the first one has 1 log, which means you're going to expand. The second one has multiple logs, which means you're going to condense. So if I expand and I have the 4th root of x over y squared and z to the 3rd, I'm expanding into addition and multiplication, subtraction, right? What's going to be positive and what's going to be negative? What gets a positive sign? Good. The x to the 4th, I'll leave it like that for now. And what gets a negative?
Y squared and z.
Good. Both the other two. They are both in the bottom. Now, if the square root is 1/2, what is the 4th root? 1/4. And then what happens to all those exponents? Good. They move to the front of the individual logs. So the last thing that we do when expanding is bump the exponent, which means we reverse it if we're condensing. It's the first thing that we do. So on that second example, the 4 becomes the exponent on the y. The 1/2 becomes the exponent on the z. Which of these stay in the top and which of them go to the bottom? Good. So the y goes to the bottom, the other two stay in the top, right? So log x, and z to the 1/2 becomes? Square root of z, and y to the 4th goes to the bottom. Okay, then came solving. So 3/4 was solving logs and exponential equations. We said there's like 4 types of problems in here, okay? There is where there is 1e. Actually, let me stick to the easiest. There is where there is exponential on both sides. That's the first kind. And for those, your goal is to see if you can get the base to be the same on both sides. If you can, then you just set the exponents equal to each other. The other is if you couldn't get the exponential or the base to be the same on either side, then you have to ln both sides of your equation. So I'll show you an example of that in a second. Then there was if there was 1e on one side of the equation, and for those, you want to isolate the e and then ln both sides of your equation. Then you had where there was 1 log or 1 ln. And for those, you wanted to convert into exponential notation and solve it, but you've got to check those. And then the last kind, if there was 1 ln or log on either side of the equation. Actually, it didn't have to be 1. As long as there's a log or an ln on either side of the equal sign, then you would use that same change of base, except this time you might have to condense. If there's 2 logs on one side, you've got to condense it first. Some of these questions are going to be on the calculator portion, and some of them are going to be on the non-calculator portion, because you can do both, okay? So think about, like, this is not going to go in a sequential order. You're not going to get the simplify and then solve. It's going to be kind of mixed together. Make sure you read your instructions. So if you saw something like 2 ln of x plus 8 equals 12, this is an example where you have 1 log on one side, right? What's my goal there? So I got to get the ln of x by itself, yeah? And then make it log base e and get it into exponential. So I would subtract the 8 from both sides. Divide both sides by 2. And then convert ln into log base e and can get that into exponential. So e to the second equals x. If this was not on the calculator portion, that's as far as you'd go. You'd leave it as e to the second. If it was on the exponential, on the calculator portion, then you'd continue to figure that out, which is 7.389. And I got negative 14 plus e to the 4x equals 9. So a single e, what do I do here? Say again. ln both sides. So first I got to isolate the e, so I'm going to add the 14 to the other side. And then ln both sides of your equation. Ln e to the 4x equals ln 23. ln of e cancels, leaving you your exponent. So 4x equals ln of 23. And then I want that x by itself, so I divide by 4. So again, without a calculator, I can get to this point. With a calculator, I would find ln of 23 and divide it by 4. Okay, here I've got two bases that are not the same, and there's no way to rewrite 5 as 2 to a power. So what do? You're going to ln both sides of your equation. Or log both sides, because they both work, right? You can do both. So if I bump the 3 to the front, I'd get 3 ln of 5 equals x ln of 2. And then my goal is to get x by itself. So I'm going to divide both sides by ln of 2. And I get x equals 3 ln of 5 over ln of 2. Without a calculator, it stays that. With a calculator, I do 3 ln of 5 divided by the ln of 2. .9657, so 6.966. And again, it would have worked the same if I had done log. So you can either log or ln. The goal is to get those exponents to get pushed to the front. All right, this one has multiple e's, so I can't combine them into one term. I can't isolate the e by itself, which means I've got to do what? Factor these. These are easy. Don't make them harder than they are. It's just e to the x and then e to the x. And then the factors of -3 that sum to -2, which is what? Good. -3, +1, set these each equal to 0. E to the x equals 3, and e to the x equals -1. And then to solve an e to the x, I'm going to ln both sides of the equation. This side becomes x equals ln of 3. ln here, ln e to the x equals ln -1, and I'd get x equals ln -1. Can you find the log of a negative number? No. So if you didn't have the calculator, you would have to know to rule that out because you can't find log of a negative number. If you had the calculator, it would yell at you. Okay, and then you couldn't find it. So ln of 3 would be 1.0986, which is 0.99. And then the last question is similar to the one that we did from the 3.1 to 3.4 review. You've got logs on either side of the equal sign. So I got to condense the ones on the left. It's addition, so it becomes multiplication. And then because there's the same log on either side, I'm actually going to multiply it out. I get rid of the log, subtract the 3x, add the 2, and this, because it starts with a log, has got to get checked. So I want to plug the 6 into both of those places and make sure what's there will stay positive and non-zero.